Hello students, I am Professor Sanjay Bhargav, MSc in Physics, PhD with a teaching experience of more than 38 years. Today, I am going to introduce some basic aspects of electrostatics for you. Electrostatics is a branch of physics in which we study about electrical forces, fields and potentials produced by a stationary charge. Now, the word electrostatic is made up of two parts, electron and static. Electron is a representation of charge, while static means at rest. That is why in electrostatics we study properties related to stationary charges. The first question that comes to my mind is, what is charge? Charge is a scalar physical quantity. Why scalar? Because it adds according to the scalar laws of addition. Why physical quantity? Because it can be measured. Charge can only be given to the bodies which possess mass. While I can say, then what does the charge do? It produces electric and magnetic interaction. So, what are the important properties associated with the charge? Charge, we can say, is a derived quantity with SI unit coulomb and dimension ampere power 1 T power 1. Charge is a scalar quantity, as I said, because it adds according to scalar laws of addition. Charge is associated with massive bodies, that is, the bodies which have mass can only be given charge. For example, we have certain bodies with zero rest mass. What are the examples of zero rest mass bodies? We can imagine about a photon, neutrino and antineutrino. Since they have zero rest mass, so no charge can be given to them. Another set of example is bodies which possess mass like electron and proton. What is the mass of the electron? The mass of the electron is 9.1 into 10 raised to power minus 31 kilogram. So electron can be given a charge of minus 1.6 into 10 raised to power minus 19 coulomb. Proton. Mass of the proton 1.67 into 10 raised to power minus 27 kilogram. What is the value of the charge with the proton? 1.6 into 10 raised to power minus 19 of coulomb. There are two types of charges, positive charge and a negative charge. The gain of electrons by a body produces negative charge, while loss of electrons produces positive charge. I have a body of mass m. When the body is negatively charged, that means it gains electrons. So a small incremental increase in mass takes place. What does delta m represent? Change in mass due to transfer of electrons. Similarly, a body of mass m, when positively charged, will lose certain electrons. So a small decrease in mass delta m takes place equivalent to the mass of lost electrons. Remember, delta m is usually very small. Charge is transferable from one body to another. Like when we rub two bodies, one of the body loses charge, another body gains equal amount of charge. So what do we say? Charge lost by one body would be equal to charge gained by another body. Like charges, they repel each other, while opposite charges, they attract each other. One of the questions that we face is, what is the short test of electrification? So repulsion is a short test of electrification because it happens between two similarly charged bodies. Attraction may take place between two oppositely charged bodies, but also may take place between a charged body and an uncharged body. That is why we say repulsion is a sure test of electrification. Another property of the charge is conservation of charge. For an isolated system, the total charge on the system is always conserved. The total charge on the left hand side would be equal to the total charge on the right hand side. For example, we imagine decay of a neutron into proton and electron with emission of antineutrino. The total charge on the neutron on the left hand side is 0. While on the right hand side, proton carries a positive charge, electron carries a negative charge, and therefore the total charge on the RHS is also equal to 0. Another example in which uranium-238 decays into thorium-234 and helium-4. What is the total charge on the left hand side? 92 times the electronic charge. What is the total charge on the right hand side? 90 times the electronic charge and 2 times the electronic charge, making it once again 92 times electronic charge. Since the total charge on the left hand side and the right hand side are equal, so what does physics say? Such a process is physically possible. Similarly, uranium-235, when is bombarded by slow moving neutrons, then it converts to barium and krypton with the emission of 3 extra neutrons and energy. What is the total charge on the left hand side? Equal to the 92 times the electronic charge. Similarly, what is the total charge on the right hand side? 56 times E plus 36 times E makes it once again 92 times E. Since the total charge on the left hand side and the right hand side is equal, so we say such a process is physically possible. Quantization of a charge. Charge is a quantized physical quantity. What does it mean? It means that total charge on a body is always an integral multiple of charge on an electron. That is 1.6 into 10 raised to power minus 19 coulomb. So charge on a body Q would be equal to N times E. What is N? N is an integer. Now, certain questions that come to my mind are, is the charge 1.6 into 10 raised to power minus 18 coulomb possible? Let us check. 1.6 into 10 raised to power minus 18 coulomb would be equal to 1.6 into 10 raised to power minus 19 multiplied by 10 raised to power 1, which makes it as 10 times E. So the total charge is an integral multiple of basic unit of charge. Therefore, 1.6 into 10 raised to power minus 18 coulomb is possible. Is the charge 1.6 into 10 raised to power minus 20 coulomb possible? It can be written as 1.6 into 10 raised to power minus 19 into 10 raised to power minus 1. So it is E by 10, a fraction of E. What does the quantization principle say? Fractional charge is not possible. How to calculate how many electrons would be required to produce a charge of 1 coulomb? According to the equation, the number of electrons N can be written as total charge upon E. Total charge is 1 coulomb divided by E, 1.6 into 10 raised to power minus 19 coulomb. On solution gives 6.25 into 10 raised to power 18. So 6.25 into 10 raised to power 18 electrons are required to produce a charge of 1 coulomb. How are the charges produced? Charges are produced by 3 different methods. Conduction. When a charged body comes in contact with another uncharged body, then the charge flows from one body to another. That is called conduction. Second method is induction. When a positively charged body is brought closer to another uncharged body, it induces equal and opposite charge in the opposite body. Action at a distance. So it is called induction. Another is friction. When the two bodies are rubbed against each other, then it causes transfer of electrons from one body to another, producing charge on both the bodies which are equal and opposite, and that is called friction. How do we measure or detect a charge? For that, we require an instrument called either gold leaf electroscope, a ballistic galvanometer, a voltmeter, or an electrometer. Now we have charge. We have said opposite charges attract, like charges they repel. Then with what force do they attract and with what force do they repel? The force is calculated through Coulomb's law. What does it say? The electrostatic force of attraction or repulsion between two stationary point charges is proportional to the product of magnitude of the charge and inversely proportional to square of the distance between their centers. The direction of the force is always along the line joining the center of the two charges. Here we have two charges Q1 and Q2. This is Q1 here and this is Q2. Their centers are separated by a distance r. So what does the Coulomb's law say? Force must be proportional to product of the magnitude of the charges, must be inversely proportional to square of the distance between them. Combining both these, we obtain F would be proportional to Q1 Q2 upon R square. To remove the proportionality sign, I require a constant. So F would be equal to K Q1 Q2 upon R square. K can also be written as 1 upon 4 pi epsilon 0. So what we say? K is equal to 1 upon 4 pi epsilon naught. K is called the electrostatic constant and has a value of 9 into 10 raised to power 9 Newton meter square upon Coulomb square. While epsilon naught is called the permittivity of free space. And what is the value of permittivity of the free space? It is 8.85 into 10 raised to power minus 12 Coulomb square upon Newton meter square. Now the basic question that comes to my mind is, what is permittivity? So permittivity is measure of the ability of the medium to allow the electric field lines to pass through it. What are the different properties of the electrostatic force? Electrostatic force may be attractive or repulsive depending upon the polarity of the charge. It's a medium dependent force. Force between two charges would be maximum in vacuum. Electrostatic force is a conservative force. So what is conservative force? A force is said to be conservative if the work done by the force along a closed path is zero. The work done by the conservative forces depends only on initial and final position and is independent of path. Electrostatic force is a central force. Why? Because it always acts along the line joining the center of two charges. Another property, electrostatic force forms a pair of action and reaction forces. Let us imagine two charges Q1 and Q2 separated by a distance r. Q1 would be repelled by Q2 to the left, force on Q1 due to Q2. Similarly, Q2 would be repelled by Q1 to the right, force on 2 due to 2,1. The product Q1 Q2 is greater than 0. What does that mean? Both the charges are identical. Either both are negative or both are positive. What would be the force on Q1 due to Q2 as per Coulomb's law? F12 K Q1 Q2 upon R square, and the direction is R21 from 2 to 1. What is R21 cap? It's a unit vector from Q2 to Q1. Similarly, I can evaluate what is the force on charge Q2 due to Q1. F21 would be equal to K Q1 Q2 upon R square R12 cap. R12 cap is a unit vector from Q1 to Q2. Here both the forces F12 and F21 are equal in magnitude, opposite in direction. So form a pair of action and reaction forces. Since the two unit vectors are equal in magnitude, opposite in direction, so both the forces are equal in magnitude and opposite in direction, or they can be written as F12 plus F21 is equal to 0. What does that mean? It says that the sum of internal forces F12 plus F21 is equal to 0. Thus, net force acting between a pair of charges is 0. Now I want to define relative permittivity or dielectric constant. What I do is I calculate force between the two charges Q1 and Q2 in vacuum. So force in vacuum 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. What is epsilon naught? Permittivity of free space. Similarly, force between the same two charges Q1 and Q2 in a medium. So force in medium would be 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Epsilon is called permittivity of a medium. The ratio force in vacuum to force in medium upon force in medium would be equal to epsilon upon epsilon naught, and this ratio would be called as relative permittivity or dielectric constant, normally represented by this letter K, pronounced as kappa. So force in medium is equal to force in vacuum upon epsilon r. Let us find some standard values of relative permittivity. Epsilon r is a unitless and a dimensionless quantity, as it is the ratio of two permittivities. It's a pure number. For air, epsilon r is 1. For water, it is 81, and for metal is infinite. How can I define permittivity? That is relative permittivity. It is defined either by this equation, epsilon upon epsilon 0. So it is defined as the ratio of permittivity of medium to permittivity of free space. In terms of forces, it is defined as the ratio of electrostatic force between two given charges separated by a given distance in a vacuum to the force between same two charges separated by the same distance in a medium. Now, what is SI unit of charge? Coulomb. So we need to define what is 1 coulomb. The force F is equal to K Q1 Q2 upon R square. If Q1 is equal to Q2 is equal to 1 coulomb and R is equal to 1 meter, then F will be equal to K equals 9 into 10 raised to power 9 Newton. So 1 coulomb is that charge which, when placed at a distance of 1 meter in vacuum from another similar stationary charge, repels it or is repelled by it with a force of 9 into 10 raised to power 9 Newton. What are the CGS units of charge? 1 coulomb would be 3 into 10 raised to power 9 ESU of charge. ESU means electrostatic unit of charge, that is stationary coulomb. Or it is equal to 1 by 10 of EMU of charge. EMU means electromagnetic unit of charge, that is absolute coulomb. EMU upon ESU would be equal to 3 into 10 raised to power 10, that is speed of light. So the two CGS unit are related as EMU of charge. They find 1 EMU upon 1 ESU would be equal to C, that is the speed of light. Another small question for you. Find the force between two charges Q1 and Q2 when a metallic plate is kept between them. How to calculate? Force in presence of a metallic sheet would be equal to force in vacuum upon epsilon r for metal. And what is the value of epsilon r for metal? Infinite. So force in vacuum upon infinity would be 0. What does that physically mean? It says that the force between two charges Q1 and Q2 becomes 0 when a metallic plate is kept between them. Thus, by keeping a metallic plate, you can reduce the force between the two charges to 0. So, thank you for the day. We will be continuing with this in the next lectures to come. Thank you.